Hello. So in the previous videos, we talked a bit about inequalities, introduced the concepts, introduced the symbols, talked a little bit about solving inequalities. However, in this video, I'm going to talk about a special consideration for inequalities. So to kind of recap what I was talking about in the previous video, imagine I had something like 2x, or 2x plus 6 is greater than 3, or maybe 4, make the numbers nicer. If I were to solve for x, I want to get x by itself, and this inequality symbol seems scary, but remember, we just kind of treat it as though it was an equal sign for a moment, because when we ultimately graph our inequality, whatever the number is, whatever x will be, the end result, we're either going to point away from it to the right or to the left. And we might either have this filled in, or we might have it, we either might have it open, as in the bottom here, or we might have it as a filled in dot. But either way, we're still going to include the edge case on our graph. If it was greater than 4 here, let's imagine we just solve this real quick so we can put our number down. So minus 6 on both sides, treating it like it was an equation. We have 2x is greater than negative 2, x is greater than negative 1. If this was, if this was a negative 1 on my graph, that looks, drawing, man, it's a nightmare. I'm just going to draw a new graph entirely. All right, if I had my graph here, imagine tick, there is a negative 1 right there. Our graph would be starting at negative 1 and going to the right. And so when we're trying to figure out what our graph should look like, when we have this nice crazy expression here, we can solve for the number at which we consider our variable to be equal to, if we were to include like the equal sign here. So if this was greater than or equal to, that value that would be the same as the value you get by solving this equation is going to be precisely this value. That's kind of like the start of our little solution set. So we solve it through, and we got that x should be greater than negative 1. However, there is something we need to consider, and that is the case where we have what we call a negative coefficient. So remember, if you have a variable, the number in front of it, here the negative 2, is called a coefficient. And if it is a negative coefficient, meaning there's a negative sign here, there's an interesting result that occurs. So for instance here, I can start by solving this expression the same way, and I get negative 2x is greater than negative 2. However, if I were to divide by negative 2 both sides, if this was an equation, we would say, well, same thing over itself, that's just equal to 1, so we have x on its own is equal to a positive 1. However, negative signs are a little trippy, and right now we initially had that negative 2x was greater than negative 2. Question is this symbol still correct? For instance, give me a number that's greater than 1. Some of you might say 2. Well, 2 satisfies this expression. However, we got this expression from the one before it. Let's verify to see if 2 is going to work for this expression. Well, negative 2 times 2 should be greater than negative 2. Might be able to see that negative 2 times 2 is negative 4. Is that greater than negative 2? Well, remember, graphically, we like to think about this as if you have a number here, call it A, or maybe we'll just use these number here, negative 2, negative 4, maybe 0 is right here. If you are further to the left, you are less than. However, here we say that negative 4 is greater than, which means the negative 4 would have to be on this side of negative 2, but it's not. And so we get this confusing predicament where we tried to follow the same steps as we did in a regular equation, and we got an answer that doesn't really make sense. So, the correct way to do this, okay, I'll spoil the surprise first, is that when we do this, we ought to flip the sign. And so here, we actually see that we would consider the answers that are less than 1. Interesting. Well, this has a little bit to do with directionality. So first of all, our two options here for when we solve for the variable is that in either case with the symbols, we're still involving the numbers x and the number 1. So imagine if I go to my number line, I'm going to draw a new one perhaps, and I have a number line here. I still have this number 1, but you got to consider the numbers that are less than 1 and the numbers that are greater than 1. And of course, this number 1 in of itself. If I were to, first of all, just divide by 2 and not negative 2, I get to a spot where I have negative x is greater than, well, negative 1. Here, let's go ahead and ask the question, what number, if I take the opposite of it, is going to be greater than negative 1? Well, to do this, let's go ahead and plot some other numbers. So I plot 0, I plot negative 1. What are the numbers that are greater than negative 1? Well, everything that is to the right of negative 1. Well, what numbers, when I take the opposite, when I take the opposite of those numbers, land me here? Well, what does it mean to be the opposite? Well, I'm going to draw a second number line here, or a third one, I guess. If you think about the numbers 0, 1, and perhaps negative 1, if I took 1, and then I said, what is the opposite of 1? You'd probably tell me it'd be negative 1. If you think about 0 as the great divide between the positive and negative numbers, then putting a negative symbol should mean the opposite, go the opposite side of 0, but the same amount, the same distance. For instance, this distance here is 1, and this distance here on the left is just 1 as well. However, we put the negative 1 to represent the opposite side. Now, what if I said the opposite of negative 1? Well, the opposite side of 0 from negative 1 is just 1. And so these negative signs I encourage everybody to think about as flipping the side of the number line that we're on. All right, now here comes the fun part. What numbers, when I flip them, give me this desired segment? The numbers that are greater than negative 1, which is what we want. We want the numbers here, that they're the outputs, the final results that give me greater than negative 1. Well, let's consider some of these. Let's look at the number 1, because this number 1 right here is in my solution set. It's on this line. So, of course, like 1 is greater than negative 1. But negative times what number equals 1? Negative 1. The opposite of some number is going to be greater than negative 1. 1 is such number. 1 is a number that's greater than negative 1. So, what number, if I take the opposite of it, gives me 1, which is a number that works? Well, divide by negative 1 on both sides, you get x equals negative 1. So x equals negative 1 is a solution here. What about 0? 0 is on here as well. Well, hopefully you realize what number times negative 4. What's the opposite of 0? Well, first of all, 0 is greater than negative 1. 0 works. 0 is right here. Now, the edge case that I was talking about in the other videos, for instance, if this was greater than or equal to negative 1, well, what number, if I were to take the opposite of it, gives me negative 1, we'll divide by negative 1 on both sides, x is equal to 1. right here on the Great Divide. And you may notice, if I were to start here and then travel in the opposite direction, in the direction of my solutions, it's like we just flipped this solution set that was for the initial expression, but we're taking the opposite of it. We flipped it across the great zero dividing line. So here's 0. We're kind of flipping all of these points across this line. These points are kind of flipping to their opposite parts. What you may notice also is that, essentially, because we're doing this flipping motion, our inequality, instead of being greater here, it's now going in the opposite direction. As you get bigger and bigger further along on this side, you will also get further negative on this side, because you were just flipping it. And so with our initial solution set, I'm going to take this away. Here, when we have this negative here, if we want to divide by this negative, or if we wanted to initially divide here, we'd wind up at x is greater than 1. Or less than 1. Because the direction of our solution flipped when we divided by the negative. We went from this guy to this guy. The direction flipped. And so whenever you see yourself either multiplying or dividing by a negative, remember, that's going to flip your number to be the opposite of that number. If it was a negative 3, it would flip it to be a positive 3. So your solutions are going to be swapped. So this is like the one consideration. And of course, I will remind everybody, why is this not the case with, like if I say negative x equals negative 1, why do I not flip this symbol, the equal sign? Well, remember, if we were trying to read the equal sign, I can say negative x equals negative 1, or I can say negative 1 is the same as negative x. I'm saying it the same words. Okay, of course, I spoke different words there. Negative x is the same thing as negative 1. Negative 1 is the same thing as negative x. Here, with the greater than or equal to signs, remember, you read this as greater than when you're reading from left to right. I say negative 2x is greater than negative 2. Here, I say negative 2 is less than negative 2x. There is directionality in the symbol. It's not the same both ways. And so yeah, I really hope this helps, and hopefully this makes sense to everybody, that when you divide by a negative, you are then flipping your solution set across essentially the magical 0 dividing line. And yeah,